The vertical line test is something that you're going to hear about in the future also when we're talking about functions. All it basically says is that if you have a function, you put a vertical line through it, and if it only touches in one place at one time, then it is a function. So a graph represents a function when no vertical line passes through more than one point on the graph. So this is a function because my vertical line is only going to touch in one spot ever. This is not a function because my vertical line is going through two different points right there. Okay, so let's look at this. And let me, I was going to grab a ruler, but that's okay, we can see it. Okay, my vertical line test. I have a line that can go through this dot, but look at this. I also have a vertical line that will go through two dots. So this is, by the vertical line test, this is not a function. Okay, but if I come over here, I could take vertical line and just move it on over, and it is only going to hit one point at each place. So this is a function, and I know that from the vertical line test. Okay, so I want you to do these on your own, see if they are functions, and go ahead and pause your video. Okay, so if I look at my vertical line again, I can go through each one of these, and I'm only hitting in one spot. So this is a function. I forgot to start my timer. That's not good. Okay, this one also, my vertical line test. Okay, I go through it, and this is a function because my vertical line test will always only hit in one spot. How about this? I can draw one line, and even if just one line goes through two, it's not a function. So this is not a function. Okay, and finally, this is an absolute value function, and if I were to draw vertical lines through, there aren't any places that I'm going to hit it more than once. So this one is a function. Okay, here's some more vocabulary. Okay, you're going to hear about the domain and range a lot, so this is something that you need to know. The domain is all possible values of x, or the inputs. It's what x can be. At this point in math, probably x is going to be all real numbers for you guys, for a lot of what you're doing. Okay, not always though. Okay, the range is all possible values of y, or f of x. Okay, this is something you probably haven't seen before. We also call y f of x. Okay, and we'll cover that more another time. All right, so find the domain and the range of the function represented by the graph. So I have to remember that my domain is my x values. So if I look at my coordinate pairs here, I've got -3, -2. I have -1, 0. I have 1, 2. And I have 3, 4. Okay, so my domain is going to be all of my x values. So I have -3, -1, 1, and 3. My range, or my y values are going to be -2, 0, 2, and 4. Okay, so that's easy to do when we've got these solid dots. But what do we do when we have something that's continuous? Okay, that it covers all of these things. Well, this is when we use intervals, and this is going to look familiar. Okay, so if I'm looking at my domain, okay, it starts right here, and it goes to here. Okay, so I'm going from -2 to 3. Well, how do I write that as an inequality? I write it like this. Negative 2 is less than or equal to x, which is less than or equal to 3. And remember interval notation, that would be negative 2, 3. Hopefully you can see this marker. Okay, for my y values, I'm going from here to here. Okay, so I've got this part. So I am going from negative 1 to 2. So my range, negative 1, oops, I meant negative 1, negative 1 to 2. So it would be negative 1 less than or equal to y, which is less than or equal to 2. And in interval notation, it would be written like this. Okay? All right, so that's a little bit on domain and range. Okay. The variable that represents the input values of a function is the independent variable because it can be any value in the domain. Okay, so I can put into my machine, into my function machine, whatever I want as long as it's in the domain. So the domain is a set of numbers, and maybe the domain is all real numbers, so I can put anything I want into this machine. But I don't necessarily have control of what's coming out because of what the machine is doing to those numbers. Okay, so the stuff I put in is the independent variable. The stuff that comes out is the dependent variable. So the variable that represents the output values of the function is the dependent variable because it depends on the value of the independent variable. So what I put in, okay, I can put whatever I want in, and that is going to be, like I said, transformed and something's going to come out. But what comes out is dependent on what is put in. So here's an example. The function y equals negative 3x plus 12 represents the amount y in fluid ounces of juice remaining in a bottle after you take x gulps. Identify the independent and dependent variables. So I can take as many gulps as I want, but, how do I say this? But how many gulps I take is what is making the amount of fluid go down. And so what I do is affecting that amount of fluid. So one's independent and one is dependent. So my independent variable is also my x value. So that pretty much tells you exactly what it is here. So my independent variable is x, and my dependent variable is y. So whatever it is that I'm doing to x totally affects what happens to y. Sorry, I'm all tongue-tied today. So whatever I do to x is going to affect y. Okay, so it also asks, the domain is 0, 1, 2, 3, and 4. What is the range? So remember, the domain is my x value. It's what I'm going to put in. So if I put in 0 gulps, that pretty much tells me how many fluid ounces of this juice I have. So I have 12 fluid ounces. Okay? If I take 1 gulp, I'm left with 9 fluid ounces. I should do this. Okay? If I take 2 gulps, I have 6 fluid ounces. I take another gulp, and I'm left with, I'm left with 3. And one more, my 4th gulp gives me 0 fluid ounces. So I just drank 12 ounces of juice in 4 gulps. I wonder if I could do that. Somebody try that, would you? And see if you can do it in 4 gulps. They'd have to be really big gulps, I think. Anyway, okay, so that means that my domain is 0, 1, 2, 3, 4. My range, okay, or what comes out, my dependent variables, are 12, 9, 6, 3, and 0. All right, so that's it for this section. Your homework is right here, numbers 3 through 18. It will be in Big Ideas. This is kind of an interesting thing. It's a graph that's kind of circular because it's going through the colors. And it shows the hue densities across film trailers. So they took colors from movie trailers and made a graph out of them, and this is what they came up with, which I think is so interesting because it looks to me like there's probably a lot of fire or explosions maybe in film trailers, and then maybe, I don't know, sky or something. Anyway, I just thought it was kind of cool. So, as always, if you have any questions, make sure you let me know.